Hello, we are Collabuilder, and the problem we sought to solve was to create agents that would work together and build a home. They should be able to take some user-defined blueprint and figure out a way to build the house regardless of complexity. For this final build, we focused on creating a working model that would be further extended for later use. There are three main aspects we focused on to train our agent. The first is the general structure of the model, which is a convolutional neural network. The input to the model is a 5-dimensional array which is composed of a 3-dimensional world space, a channel containing the current state and the goal state, and a channel representing block types. This would be convolved for 2 to 3 layers before reaching 2 to 3 layers of fully connected nodes. At the end, the output contains an estimation of Q values for an action which the agent picks the maximum of. The second aspect is how the model learns. We used as our baseline double deep Q-learning network, which allowed it to learn near-optimal action lists without needing explicit programming. We chose double DQN as it lowers the chance of suboptimal actions being given higher Q values than an optimal solution. This is extended by using a dueling network, where the state reward and the action rewards are separated out, allowing for better generalization of the actions to take. The third aspect is what lesson to use, which we handle by using a curriculum learner. This allows the agent to learn good and bad actions without being overwhelmed by the detail of the blueprints.
Now let's look at our models. Our baseline agent implements a simple breadth-first search algorithm, which is able to solve any blueprint we give it in a very reasonable time. Looking at our initial DQN models, it doesn't seem very good. However, going through the lessons, the agent does get better. We had two main approaches for our models. The first is our regular double DQN model. We tested it with a large arena with a moderately complex blueprint. This model did not fully complete the blueprint. However, with sufficient training, it is very likely it would complete it. On the other approach, we had the dueling DQN network. This was tested on a slightly smaller arena size. However, we trained this model towards a more vertical type blueprint. As one can see in this simple example, this agent is successfully able to complete the vertical challenge of this blueprint. Comparing both of these models to the baseline, we see that they were not able to fully match the capabilities of our baseline agent. However, with sufficient training, they are likely to at least approach and maybe even surpass our baseline agent. For potential future research, we would like to see how these two models work together. The first one primarily focused on a floor or foundational type blueprint, whereas the second one focused more on wall type blueprints. These two agents together could perform much better than the baseline agent could alone.
Thank you for watching.